What if I told you that the clicks and calls of a sperm whale aren't just random sounds, but structured, conversational turns? And that recent breakthroughs in AI are letting us see that structure for the first time? For centuries, we've seen whales as majestic creatures, swimming through the vast depths of the ocean. We've marveled at their size and their power. But we often struggled to imagine the complexity of their inner lives. But the science is now pointing to a stunning reality, a level of intelligence and social depth that challenges our own place in the world. We're on the verge of understanding not just what they're saying, but who they are. For most of history, whales have been figures of myth and legend, monsters of the deep, or gentle giants. We saw their colossal forms breach the surface. We heard their haunting songs echo across the waves. But we had no way to comprehend the minds that produced them. Our understanding was limited to what we could see from the deck of a ship. We assumed the clicks of a sperm whale were simple signals for navigation. Like a kind of biological sonar. We thought the complex songs of a humpback were little more than elaborate mating calls. But what if we were wrong? What if the simplicity was not in their minds, but in our understanding? What if we've been listening to a symphony, but only hearing a single note? The evidence that is now emerging is forcing us to question everything we thought we knew. We are standing at a precipice. Looking into the minds of another species in a way that has never been possible before. And what we are finding is not only changing our perception of whales, but it's forcing us to reconsider the very definition of intelligence itself. Our journey to understand the minds of whales is a story that's deeply intertwined with our own. For most of human civilization, our relationship with these animals was one of distance and utility. They were resources to be harvested or distant spectacles to be admired. The idea that a whale could possess an intelligence that could be compared to our own would have been dismissed as pure fantasy. The very world they inhabit, a world of pressure and darkness so alien to our own, made them seem impossibly different. Creatures of instinct, not intellect. While scientific study in whaling began back in the 19th century, modern behavioral research didn't really take off until the 20th century, and it was incredibly difficult. How do you study an animal that spends most of its life in the crushing depths of the ocean and can travel across entire ocean basins?
Early researchers were mostly limited to studying beached carcasses or observing whales for the brief moments they surfaced for air.
This gave us valuable insights into their anatomy and migration. But it was like trying to understand human society by only studying our skeletons and our travel itineraries. It told us what they were, but gave us almost no clue as to who they were. The tools of the time simply weren't up to the task. Then came hydrophones, underwater microphones, which began to reveal that the ocean was far from silent. In the mid-20th century, scientists first confirmed that sperm whales were vocal, producing the rhythmic clicks we now know as codas. Yet, even with this discovery, the initial interpretations were conservative. These sounds were largely thought to be a form of echolocation, a biological sonar used to navigate and hunt in the pitch-black abyss. It was a functional, mechanical explanation for a complex behavior. The idea that these clicks could be a form of communication, a language, was still on the fringes of scientific thought, though it was discussed. When researchers in the 1960s began to document the complex songs of humpback whales, again, the prevailing theory was that they were primarily for mating. The paradigm was pretty simple. Humans had language, animals had signals. Our communication was complex and symbolic. Theirs was instinctual and repetitive, limited to basic concepts like danger, food, or mate with me. This view was reinforced by a kind of cognitive chauvinism, a deep-seated belief that our species stood alone at the pinnacle of intelligence. A big part of the problem was how we measure intelligence in the first place. We have a tendency to use our own yardstick. We look for tool use and problem solving in ways that we recognize. Whales, having no hands to build with and living in a fluid, three-dimensional world, were bound to fail such a biased test.
Their intelligence evolved under a completely different set of pressures. It was an intelligence built for social cohesion in a vast ocean. For navigating a world of sound, not sight. And for coordinating life within a complex family unit.
The limitations were not in the whales, but in our ability to perceive them. We were like someone trying to appreciate a masterpiece of music from inside a soundproof room. We could see the vibrations, we could analyze the sheet music, but we couldn't hear the melody. The true nature of their intelligence remained hidden, waiting for a technological and conceptual revolution that would finally allow us to listen. The first big clue that we had been profoundly underestimating whales was hidden inside their skulls.
For decades, the sheer size of the whale brain was known, but often dismissed.
The sperm whale, for instance, has the largest brain on Earth, weighing up to 9 kilograms, more than 6 times the size of an average human brain. For a long time, this was explained away as just a necessity for managing such a massive body.
But this explanation started to fall apart.
When you compare brain size relative to body size, a measure known as the encephalization quotient, or EQ,
ranking among the top mammals.
This wasn't just a brain for running a big body. This was a brain with a lot of extra processing power. The real revelation, however, came when scientists began to look not just at the size, but at the structure of the cetacean brain.
And what they found was fascinating.
The whale brain had evolved on a completely different path from primates. While our brains are known for a heavily developed frontal lobe, the whale brain's complexity is concentrated elsewhere. Their neocortex, the part of the brain linked to higher-order thinking and perception, is astonishingly convoluted, even more folded than a human's, creating a massive surface area for neural connections. But perhaps the most startling discovery was the presence of a special type of neuron called the von Economo neuron, or spindle cell.
These were once thought to be limited to humans and great apes, but we now know they also exist in elephants and, fascinatingly, in the brains of many whale species.
These cells are found in brain regions associated with complex social emotions, empathy, and our intuitive gut feelings.
Finding them in whales suggested a profound case of convergent evolution. Two completely different evolutionary lines, separated by nearly 100 million years, had independently developed similar neural hardware for high-level social. This discovery was a direct challenge to the idea of human uniqueness.
It implied that whales might experience a rich social and emotional life. Researchers like Lori Marino have argued that the unique structure of the cetacean brain is perfectly suited for their social world.
Living in an environment where visibility is often low, and where your family might be spread out, demands an intelligence based on acoustics, on processing complex sound to understand not just where others are, but who they are and what they're doing. This neuroanatomical evidence provided the crucial context for what scientists were seeing in the wild. It was the biological foundation that could explain the complex social structures and cooperative hunting strategies that had long been documented. It suggested that when a pod of orcas works together to create a wave to wash a seal off an ice flue, it's a coordinated, intelligent strategy. A coordinated, intelligent strategy. When a mother whale is seen carrying her deceased calf for days, this could be seen not as a simple failure to recognize death, but as a behavior that points to deep social attachment, underpinned by these complex brain structures. The discovery of the whale brain's complexity was the turn in our story. It shifted the conversation from, "Are whales intelligent?" to, "How is their intelligence expressed?" The strange clicks and haunting songs were no longer just the product of simple instinct. They were the output of a mind that was large, complex, and in some ways, surprisingly similar to our own. This new understanding paved the way for the next great leap, the attempt to decode their software. For decades, the sounds of the ocean were a cacophony of clicks, whistles, and groans that we could record but not comprehend. We knew whales were vocal, but the prevailing assumption was that their communication was a limited system of signals, not a true language. That assumption is now being systematically dismantled by one of the most ambitious interspecies communication projects.
This team of linguists, roboticists, and marine biologists is focusing its efforts on the sperm whale.
Sperm whales communicate using series of clicks called codas, which sound a bit like a mix of Morse code and popcorn.
For a long time, researchers could identify different codas, but couldn't grasp their full complexity.
The breakthrough came with the application of advanced machine learning.
By deploying an array of sophisticated listening technology, Project CETI gathered an unprecedented dataset. When this massive dataset was fed into powerful AI models, patterns began to emerge that were invisible to the human ear.
In a landmark study published in Nature Communications in May 2024, researchers from Project CETI and MIT revealed something astounding.
They discovered that sperm whale codas aren't monolithic.
Whales could systematically alter their rhythm, tempo, and even add extra ornamentation clicks based on the conversational context.
These elements could be combined in a vast number of ways, creating what the team called a sperm whale phonetic alphabet.
This was a huge deal.
The researchers found that the whale communication system possesses a combinatorial structure, a key feature of human language. This suggests that whales aren't just repeating simple signals. They appear to be combining sounds in a structured, meaningful way. While we don't know what they're saying, we're starting to see how they're saying it. Further research from UC Berkeley linguistics professor Gasper Begouche added another layer. His team's analysis suggests the acoustic properties of sperm whale calls have parallels to features of human speech, like vowels and diphthongs. It's less like Morse code and, strange as it sounds, more like very, very slow vowels. The study identified acoustic patterns that share properties with human vowel sounds, suggesting the whales can intentionally produce and differentiate between them.
This doesn't mean we can have a conversation with a whale tomorrow. The team at Project CETI has not translated whale language.
But they have discovered its phonetics, its building blocks. It's like discovering the letters and grammar of an ancient, unknown language.
We can now see the intricate structure, even if we don't yet know what the words mean.
This groundbreaking work isn't limited to sperm whales. Orcas live in pods with unique vocal dialects, much like regional accents. These dialects aren't genetic. They're learned and passed round from mother to calf, a clear sign of cultural transmission. In fact, you can distinguish one orca pod from another just by listening to their calls. Even more fascinating is how orcas adapt their communication. Fish-eating orcas are highly vocal while hunting. But mammal-eating orcas hunt in near total silence. This makes sense. Their prey, like seals, have excellent hearing. The silent, coordinated attack implies a level of planning and communication that doesn't rely on audible calls. The songs of humpback whales also provide powerful evidence of cultural learning. All the males in a population sing the same complex song, but that song evolves over time. These new versions then spread rapidly through the entire population, sometimes across thousands of miles of ocean. It's like a pop song going viral across an entire ocean, with all the males learning the latest hit. What does all of this tell us? It tells us that the ocean is a world of conversation, of dialect, of culture.
The clicks, whistles, and songs are not just noise.
They are the intricate, structured, and learned expressions of some of the most complex minds on our planet. We have spent centuries looking at whales. Now, for the first time, we are beginning to hear them. Beyond their communication, some of the most compelling evidence for high intelligence in whales comes from their social lives. Many species, particularly toothed whales like orcas and sperm whales, live in some of the most stable and complex societies in the animal kingdom. These aren't just loose groups, but tightly knit, multi-generational families with rich traditions and what can only be described as culture. The concept of animal culture, behaviors learned from others and passed down through generations, has long been debated, but whales provide some of the clearest examples. Hunting techniques, in particular, are not purely instinctual. They are taught. Consider the orca. Different populations have developed ingenious hunting strategies tailored to their prey, and these skills are passed from mother to calf. In the Crozet archipelago, orcas have mastered intentional stranding, launching themselves on beaches to catch seals.
Researchers have observed mothers patiently demonstrating this technique to their young,
even nudging them ashore and helping them back into the water.
In Antarctica, orcas engage in wave washing, where a group swims in formation to create a wave that washes a seal off an ice floe.
In Norway, they use carousel feeding to hunt herring, herding them into a tight ball and stunning them with tail slaps. These complex, regional behaviors are local traditions, cultural knowledge passed from one generation to the next. Humpback whales also show, though, this kind of foraging culture.
A technique called lobtail feeding was observed spreading from one individual to another through a population in the Gulf of Maine, a clear case of social learning.
The foundation of this cultural transmission is deep, enduring social bonds. Orcapods are often matrilineal, centered around an older matriarch.
Her offspring typically stay with her for their entire lives, creating incredibly stable family groups where knowledge can accumulate.
The matriarch is the pod's living library. She knows the best hunting grounds and survival strategies. Her role is so critical that studies have shown the survival rate of her sons drops dramatically after her death, even if they're fully grown adults.
Sperm whale society is similarly complex, centered around matrilineal units of about 10 to 12 individuals.
They engage in communal care for their calves, a practice known as alloparenting.
While a mother dives deep to hunt, other females in the group will babysit her calf near the surface.
Project CETI recently documented a rare sperm whale birth, where the entire pod gathered around the laboring mother in a protective circle.
After the calf was born, other members of the group were seen nudging the newborn to the surface for its first breaths.
Observers described it as a clear demonstration of midwifery and collective care.
A behavior that points to an incredible level of social sophistication and what looks a lot like empathy.
These aren't just behaviors for survival. They are interactions that build and maintain the social fabric of their lives.
Whales engage in complex play.
Dolphins are famous for their acrobatic leaps
and have even been seen creating and playing with bubble rings. This isn't frivolous. It's a crucial way for young animals to practice skills and strengthen social bonds. When we look at a pod of whales, we are not just seeing a group of animals. We are seeing a society, a family, a culture. And this social complexity is perhaps the most undeniable sign that their minds are far more aware and far smarter than we ever imagined. If you're as blown away by this as we are, and you want to see more stories that challenge our perspective on the natural world, take a moment to subscribe. It helps us continue to bring you these explorations into the wonders of our planet. Now, let's get into one of the most moving and profound aspects of whale intelligence: their emotional lives.
For a long time, the scientific community was hesitant to attribute emotions to animals, often dismissing such ideas as anthropomorphic.
But a growing body of evidence, coupled with our new understanding of their brains, is making it increasingly difficult to deny that
the most powerful, and often heartbreaking, evidence comes from their responses to death. Across numerous cetacean species, scientists have documented what is formally called post-mortem attentive behavior.
This has been observed in at least 20 different species.
The most common displays involve mothers who refuse to let go of their dead calves, carrying the lifeless bodies for hours, days, or even weeks, and dive to retrieve it when it slips from their grasp.
Perhaps the most famous case is that of Tahlequah, an orca from the endangered southern resident population.
In the summer of 2018, her calf died shortly after birth. For 17 days, she carried her baby's body on what became known as a tour of grief, traveling nearly 1,000 miles. She balanced the calf on her head and back, refusing to let it sink. While other members of her pod stayed close in apparent support. This was not an isolated incident. Similar behaviors have been recorded time and again. While some scientists suggest this could be a primal instinct to try and resuscitate the young, the sheer duration and apparent distress changes. The social brain hypothesis supports this idea, suggesting that animals with complex social lives and large... It isn't just mothers mourning. In these tight-knit family groups, the death of any member can elicit a powerful response. Pods have been observed lingering around the body of a deceased companion, gently touching it or circling it. These are not the actions of unfeeling automatons. They are the behaviors of socially intelligent beings coping with loss. Beyond grief, whales display a spectrum of other behaviors that suggest a rich inner world.
They exhibit curiosity and show clear evidence of excitement and joy in their play.
They also demonstrate what appears to be altruism.
There are numerous accounts of dolphins protecting swimmers from sharks, or guiding lost whales back to sea.
Humpback whales have even been observed intervening to protect other species from orca attacks. This kind of interspecies altruism is incredibly rare and hints at a capacity for empathy that extends beyond their own kind. The neurological evidence we discussed earlier provides the foundation for these emotional capacities.
The presence of spindle neurons in brain regions linked to empathy and social awareness gives a biological basis for the behaviors we see in the water.
When we combine the neuroanatomy with decades of observational evidence, the picture becomes clearer. These are creatures that form deep bonds, that care for their families, that teach their young, and that mourn their dead. Recognizing their capacity for both joy and suffering isn't just a scientific conclusion. It has profound ethical implications for how we treat them and their ocean world. So, what does it all mean? What are the real-world consequences of discovering that whales possess a level of intelligence, culture, and emotional depth that we once thought was uniquely human? The implications are vast, touching on everything from science and ethics to conservation. First, there are the scientific implications. The work of Project CETI is pushing the boundaries of artificial intelligence, robotics, and linguistics. Developing AI that can identify patterns in a non-human communication system is a monumental challenge that could lead to breakthroughs in how we analyze all kinds of complex data.
If we can successfully apply these methods to sperm whales, we might one day be able to listen in on the conversations of other intelligent species.
We are on the cusp of a new era of digital bioacoustics that could revolutionize our understanding of life on Earth.
Then, there are the profound conservation implications.
Whales face a barrage of threats from human activity. Ship strikes, entanglement in fishing gear, and the deafening noise of
For too long, we have treated the ocean as a resource to be exploited.
But if we accept that these are intelligent, sentient beings with cultures and societies, it forces us to ask some tough ethical questions. Knowing that a pod of whales is a multi-generational family makes a ship strike that kills one of them not just an accident, but a tragedy that can devastate an entire social network. Understanding that orcas have distinct cultures means that losing a single population isn't just a loss of biodiversity. It's the irreversible extinction of a unique culture, akin to losing an ancient human tribe with its own language and knowledge. This understanding adds a powerful new urgency to conservation efforts, transforming them from a practical goal into an ethical imperative.
Finally, and perhaps most importantly, these discoveries challenge us on a philosophical level.
For centuries, Western thought has been built on a foundation of human exceptionalism, the idea that we are fundamentally superior to all other life forms. Our complex language, our self-awareness, these were the pillars that held up our special status. But the science of whale intelligence is systematically knocking those pillars down. They have complex communication with features that parallel our own phonetics. They have culture and learned traditions.
Their brains contain neurons associated with self-awareness and empathy.
Whales represent an alternative evolutionary path to complex intelligence. They show us that there is more than one way to be smart, more than one way to be social, and more than one way to be conscious.
This realization is both humbling and exhilarating. It means we are not alone.
We share our planet with other minds, other societies, other intelligences that are ancient, alien, and worthy of our respect. The question is no longer just, are whales smarter than we think?
The question is, are we smart enough to listen? We began with a question, are whales smarter than we think?
After journeying through the intricate architecture of their brains, the dawning revelations of their communication, and the profound depth of their social,
they are far more conscious, complex, and intelligent than we ever imagined. From the structured, combinatorial alphabet of sperm whales
to the cultural dialects of orcas, and the mournful vigils for their lost young, the evidence points to a stunning reality. We are not the only species on this planet with culture, deep family bonds, or a complex communication system.
We are standing at the beginning of a revolution in understanding.
The work of projects like CETI, powered by artificial intelligence and a new willingness to challenge our own assumptions, we are learning that the clicks and songs echoing through the abyss may well be the conversations of another ancient intelligence on our own planet. The journey to truly understand them has just begun. What did you find most surprising about the intelligence of whales? Let us know in the comments below. And if you want to continue exploring the biggest questions about the world around us, make sure to subscribe and turn on notifications so you don't miss our next video. Thank you for watching.